And I guess, I don't know, we didn't talk about this here, but is it okay to record?
Yeah, no problem.
Yeah, okay, cool. Cool.
Good, all right.
And then just in case anything like happens for screen sharing on your end, can you send me a link to your presentation as well? And I'll have it pulled up as a backup.
Cool. But you guys can see and hear everything, right? No problem?
Yeah.
Okay, I'll stop sharing for the moment. I'll send you a link.
Cool. And then let me get your bio up and ready to read through.
As soon as you're ready to let people in, let me know.
Yeah, I'll let you know. Let's keep it a little bit. How are you both doing today?
Good. It was nice weather, and it should be. We should be under like a half a foot of snow by now here in Calgary, but we're not yet. So. All right, Aslan, so I just sent you a link to the presentation in the event something goes down. So.
Okay. Sounds good.
Wait.
All right, we're gonna go back to the Zoom. Go back to screen share. Do you guys have a pre-deck you're going to share first, or should I just share my splash?
I didn't have one.
You can go ahead, Tyre.
Yeah.
I think.
Sure, I'll just keep the title screen up then as you.
Right.
That's intro. Where this one? Yes. Okay. Good. Awesome. You guys can see it again. No problem.
Yep.
And so Arslan, I know you're on the West Coast. Prince, where are you located?
Same Jamaica, Santa Clara.
On the West Coast. Okay.
Bay Area. Yeah. Shall we get started? And I think it's
Yeah.
11:01. So
Yeah, let's let
You
people in. Yeah.
Okay.
Hey, young lit everyone. Thanks for joining the IPN hardware session this morning. We'll give people a few more minutes to trickle in, and then we'll get started. Cool. I guess while we're waiting, I will go ahead and launch a quick poll for us. If you guys could fill that out, I would greatly appreciate it. I think it'll help us kind of get a sense of who's present, and can then tailor the conversations accordingly. Cool. We'll wait for a couple more participants if you guys want to participate in the poll, and then we'll jump right into it. Cool. So it looks like we got a nice bell curve of distributions of our experience levels. So that'll be good. We get to hit on everyone. And then it looks like a majority of people have not 3D printed. So I think this is going to be a very interesting talk for everyone, even those who have, and excited to get into it. So with that, I will intro our speaker. So Tahir is a program and project manager with the innovation department with the city of Calgary. He leads projects to enable and shape engagement of various technologies. He's also a business and project management and technical services consultant via Escape Velocity Services, developing innovative mega projects at Fortune 500 companies by supporting the growth of small and medium enterprises with organizations such as Satellite Canada Innovation Network. He has also contributed to systems engineering and project management deliverables for Canada's contributions to the International Lunar Gateway Program, including Canada Arm 3. And so with that, I'd like to welcome Tahir. If I missed anything in your intro, feel free to jump in and let us know a little bit about yourself.
All right. Well, thank you. Thank you all for the opportunity to present to you today, and thank you for the invitation and the wonderful introduction. So Yalamat to you all, and it was great to see kind of the like to Arslan's point, the distribution of people that are attending today, which is great. And so the intent of today's presentation is to give you kind of a level-based knowledge of what 3D printing is all about. So there might be some folks out there that have already printed some products, which is awesome, that we might be more familiar, and there might be folks as shown that have never printed anything before or are brand new to even just understanding what this is. So to try and make sure everybody's on the same page, I thought this would be an opportunity to kind of give you a generic overview. There'll be time for questions at the end, of course. So feel free to keep your thoughts and your buttons pressed on the QA as we go along. And if you have any thoughts about even just if not questions, just commentary, welcome to accept it, to have a nice interactive discussion. Let's say at the end about perhaps where while the future is now, where the future of 3D printing may go. So I just want to double check and confirm you guys can hear me, see me okay, and see the screen.
Yep, all good.
Excellent. All right. Well, thank you for that. So without further ado, again, my name is Tahir Morali, and I'm coming to you live from Calgary, Alberta, Canada, here in the Mountain Time Zone. And it's again a pleasure to speak with IPN once again. I very much enjoy engaging with the IPN network as well as the alliances down in the United States, and I think it's a great model for what other communities, not only here in Canada but also around the world, can use to really connect their networks, connect their professionals, and build on the strength that alliances bring to network and progress and success across the community. So kudos on that, and I look forward to continuing to keep engaged. And so just very briefly, just a slide about myself, and Arslan touched a bit about my background. So I've worked in a number of different sectors across my career, including automotive, aerospace, government, oil and gas and energy. I've worked with Fortune 500 companies. I've worked, founded a startup. I currently founded and run a nonprofit organization in the aerospace and government sector, and currently I am a project and program manager at the city of Calgary. Today's presentation will be related to, of course, content and experience I've gained through my consulting company, which is Escape Velocity Services Incorporated, and so it'll be more focused on items there. The beauty of having such a diverse cross section of experience in different sectors is that you get to see what I call a lot of cross-pollination, or drive cross-pollination. And what I've had the opportunity to do is look at mature industries such as the automotive sector from a manufacturing perspective, and then look at the aerospace sector and try to understand that when it comes to, for example, batch processing and manufacturing, that building and construction of satellites used to be a one-off type adventure. And now we're looking at companies that want to put up, up to 30,000 satellites in one go. So that's an entirely different shift from the mentality of manufacturing, from a one-off, one and done product to batch, and at least in the aerospace side. And so I've been able to take pieces of different sectors and understand how I can help improve and mature certain sectors, and also take the best practices of each and implement those vice versa. So it's been an opportunity to really see the growth over the last several years and decade plus in various sectors. And I encourage that if you are interested in and want to try and understand what it's like to explore a different sector, don't hesitate. And I think a lot of folks feel that if they're in one area or one domain, that it's kind of the only place they should be, or perhaps the place they believe they should be. But certainly try to take an open mind and understand that there's a lot of really good ways you can contribute in different domains. Just not because it's not necessarily your expertise doesn't necessarily mean you can be successful at it. And I'm a board director. I've sat on a number of nonprofits. I've got a lovely family, two young daughters that are growing up. And so I take a perspective and a lens on technology, not only through my own growth personally and through my professional career, but also then where are we going in terms of what my daughters are going to be using, and whether that's looking at your handheld devices, or now AR and artificial intelligence, or AR and VR when it comes to virtual reality. There's a number of different things that are arising that are going to be completely different for when my kids grow up. So always good to kind of keep that in check and help work our way forward. In terms of my licenses, I'm a professional engineer. I studied in mechanical engineering at the University of Toronto. So a lot of technical side when it comes to 3D printing and additive manufacturing is driven from that experience. But I'm also a project management professional as well. And so I understand the impacts outside the technical sphere. And so I love starting my talks with this particular image, and this is actually my all-time favorite image from space. Space is my jam, as I would say. It is one of my expertise in terms of the sectors I've worked in. And so people might be like, well, what does 3D printing and additive manufacturing have to do with space? Actually, quite a lot. And what you can see here is this shot, just to give you some context, is an astronaut on a spacewalk on the International Space Station. This is the second last space shuttle launch that occurred, so STS-134, and that's the space shuttle there in the background. And what I love looking at this photo of, and of course being a Canadian, is that there's actually a Canadian first here as well. And so the first is the Canadarm1, which used to be on the space shuttle, and Canadarm2, which is currently on the International Space Station, are actually working together to support operations on the exterior of the space station. There's a lot of robotics that is engaged in additive manufacturing and 3D printing. It may not seem that way, but it's built on basic premise of manufacturing. And so this is a very advanced example of what robotics, or in this case, space robotics, is all about. And I've had the opportunity to not only train astronauts on the International Space Station systems and operations, but experienced what it's like to be in microgravity by flying on a parabolic flight while testing some experiments for life science research that actually occurred on board in one of these modules several years ago. So it's a very unique vantage point. And of course, the biggest piece of all of this is what's behind the space station and the space shuttle, and that's our Earth and the black abyss of space and what is to come. There's so much more that we don't know that we want to explore as a collective humanity. And it just gives you that perspective of we're heading in that direction, and technologies like additive manufacturing will absolutely make things not only affordable, but also feasible to get us that next jumping off point. So what we're going to talk about today, again, I'll keep it very high level and generic. And of course, we can try and get into details in some of the line of questioning. We'll talk about, okay, well, you've heard additive manufacturing and 3D printing. Those are two terms I'll use a lot, or I'll shorten them to be AM and 3DP. So what are they the same? Are they different? What does it mean? We'll talk a bit about the types of additive manufacturing, as well as in terms of the materials that are used and what or could be used. We're talking about first principles, so I'll take you down a journey of my own production. So I've 3D printed some things at home, but the principles that you apply to printing at a home-based, DIY printer are very similar to what you would use in the industrial scale of AM as well. We'll look at the applications of some of this technology and how it's disrupting some markets. We'll take a look at the market in terms of some of the market leaders, where it has come and grown, and how you're able to get engaged. And then we'll take any questions that you may have. So coming from the mechanical engineering background that I have and the technical background that I have, I thought I'd throw out the most technical thing you're going to see in today's discussion, and that starts with the definitions. This comes from the ASTM International Committee on Additive Manufacturing, which is essentially a technical working group comprised of experts internationally that provide insight into the progress, but also standards of manufacturing. So they define additive manufacturing as a process of joining material to make objects from 3D model data, and that's usually layer upon layer. That's different from what perhaps you may be traditionally used to with production and manufacturing, which is subtractive methods. So when you use a CNC machine, when you use a lathe or a mill, when you are producing things by cutting away material, that's called subtractive methods. What additive manufacturing is the opposite. It's actually layering material or adding material together to make a product that you would like to produce. That's the fundamental difference between old or traditional, I wouldn't say old, but traditional manufacturing methodologies. Now, there's actually certainly still a need to have those. So the way I look at additive manufacturing is that it's complementary to other existing methods of manufacturing. So by no means is additive manufacturing kind of the silver bullet that will, retire all other forms of production. That's not the case, and I'll get into that in a little bit. Then we'll also look at, so 3D printing is the other term that you probably hear a lot, and 3D printing is usually synonymous with additive manufacturing, and you'll see why. And so 3D printing is the fabrication of objects through the deposition of a material using a print head or a nozzle or other novel printer technologies. So 3D printing specifically relates to using a print head or a nozzle and sending material through it. That is a subset of additive manufacturing where 3D printing still joins material together, but it is a subset of AM. So from a technical perspective, we're talking about additive manufacturing as a whole, but we're going to be focusing on the 3D printing technology and methodology within AM. So I just wanted to clarify that in case anybody had any queries about the differences. So I took an interesting approach to this. I noted some what I call notable milestones from my own experience with 3D printing. And I'll have obviously a slide later on about kind of the general history of the sector. But in 1997, NASA actually published a paper on 3D printing and about the technology. If you're not familiar with it, so NASA on an annual basis, so NASA is the space agency in the States, they produce what's called the spin-off report every year, and they talk about how there are technologies that are being worked on and researched and developed and produced and used based on, of course, the contributions from the taxpayers to invest in giving back to the community. And that's one of the reasons why, for example, investment in the space sector is such an important contribution, is that there are technologies like 3D printing and their advancements that are then returned back into society. So NASA has been a leader in a number of different areas, and by all means, they did not create the 3D printing technology. but they've had the opportunity to understand how it can be used in production of very complex, high-end, robust parts and products for, in this case, the aerospace sector. In 2002, I had the opportunity to actually travel to the Netherlands on a military exchange, and there was the opportunity to visit the Royal Netherlands Air Force. And this was actually the first time I experienced 3D printing. And they demonstrated the concept of what's called photopolymerization, and we'll talk about the types in a minute. But essentially what it is there was a large layer of gel and a laser that was essentially pinpointing pieces and layers, layer by layer on this gel to essentially solidify that into a product. And so this table would slowly move down as the layer would, let's say, solidify the pieces of the gel layer by layer to produce a product. I'd never seen something like this before. I thought this was incredible. And those of you that are familiar with, of course, say, the groups like DARPA or the Defense Research Council here in Canada, a lot of technologies that enter commercialization that we then sometimes call, used at home, take about 10 to 15 years from the time that they're actually researched and developed within the defense application sphere. This is in 2002, so maybe keep that date in mind as we go forward. Then in 2014, of course, with my space passion and career, I followed it quite closely, especially when there's a company called Made in Space, which recently got acquired last year by Redwire, that actually put the first 3D printer in space on the space station. It started as just an experiment that we do 200 different types of experiments are done on the space station on any given day. This was just one of the other ones. Well, guess what? It turned out to be a very successful one to demonstrate that the technologies used in 3D printing and that additive manufacturing as a whole could actually be possible in the microgravity environment. And that was in 2014 as an early test. And now they've actually produced a couple other printers they put up there. And NASA now uses that printer to produce parts for astronauts to use on their spacewalks, for example, to help modify tools and do some ad hoc repairs. So there's something that turned out, somebody said, hey, let's see what this looks like. And now it's almost a mainstay on the space station 8 years later. In 2016, I had the opportunity to attend a conference called the Rapid or TCT conference, and I'll talk about that a little bit later. That is essentially North America's premier 3D printing conference. And at that particular conference in 2016, that was the first reveal by what I call a mainstream printer. So when you think about printing companies, right, you think about the HPs and the Brothers of the world, not so much the Stratasys and the EOSs of the 3D printing world. So this was the first crossover between a mainstream quote unquote printer into the 3D printing world. Hewlett Packard released their patented MFP or multifunction printer, MJF, multi-jet function printer technology. And we'll talk, you'll see a bit more about that shortly. And then 2020, just a couple of years ago, there's a company out in the Bay Area called Relativity Space. They founded themselves in 2015, but as all great startups do, took some time. Got to a point where they had a $500 million Series D raise that included a number of different investors for an entirely 3D printed rocket. Okay, so let that sink in for a second. They are building an entirely 3D printed rocket. If we roll back the clock and go back to 1997, where NASA's like, oh, maybe we could use a couple parts, for some prototyping or for some potential, in situ modifications, to today, where we're building an entire complex piece of technology that essentially explodes and launches into space. That is a huge development. And of course, the technology that they're using is very unique. So I just want to kind of set the stage of how much development has happened just from my lens of perspective in the last 25 years. So additive manufacturing, it has a number of different materials that can be used. And so again, this kind of, once you start diving into the sector a little bit and understanding whether you're building something at home or you're looking to produce a part as part of your supply chain at your office, or you're looking, you're an actual 3D printing manufacturer of components. There's a number of different steps you take to understand what you need to use for your specific design. So in good product design form, you have to understand what the end outcome of your product is. What is the expected outcomes? How will it perform? What are the tolerances and the KPIs that you want your product to meet? What materials do you need to use? If you're not going to attach something that's stainless steel to carbon steel, because that never ends well. So, you have to take all those into account when you're making your product, just as you would use any other manufacturing process and design process. Then, okay, if you decide that additive manufacturing might have some capabilities, what kind of materials can you use that are currently available through the additive manufacturing process? So here's a list of a number of different materials that are actually, in fact, used for printing. 3D printing. And so there's examples, plastics and metals are obviously big ones. When I talk about metals, we're talking right today, we are able to produce 3D printed parts made of tungsten, made of stainless steel, made of Inconel and aluminum and titanium. So there's quite a number of metals already today that can be produced, that can produce parts and products out of 3D printing. Plastics, of course, if you've ever seen a 3D printer, ever used one, you're typically using what's called a PLA material, which is essentially plastic, or ABS, very similar, depending on the strength and needs of your product. Those are very common. There are specific technologies that print ceramics. So if you need a ceramic coating on a particular product for protection, or an entirely whole ceramic piece, if you want to print a mug. Composites are big, especially now when it comes to carbon fiber and being able to optimize various mechanical properties of products and materials. And then, of course, there's other materials that are more nascent that are on their way. But that's you can do quite a lot with, and so obviously your home-based 3D printer can't do everything, and it won't. But there are companies out there that through the years have started to consolidate their market, and now are market leaders in doing literally every possible material. And of course, then added services on top of that. But we'll talk about that in a bit. And so here are just a couple of examples. These are some I printed here. I've got them as well. So this is actually a kind of helical flower design that was 3D printed on a Utilmaker 2, and that's based on PLA. And then this, as you can see here, this is actually a metal 3D printed component. It's actually very heavy. I know the focus isn't great, that's why I got a photo of it. Very small, it's the same size as about an espresso capsule, but this is fully metal additive manufactured. And this is a replica of what the Orion capsule looked like in 2016. So I talked about materials. What about types? And there's a number of different types of materials, types of manufacturing processes that are used in, let's say, the additive manufacturing space. And so the four I've bolded here are the four primary, basically the leading approaches. The others are used, but they're very specific or not as common. So the four I'll touch on today are material extrusion. So here, as I mentioned, I made this flower. That's actually the start of the production process of that flower on the Ultimaker 2. That's called material extrusion. Essentially, you're feeding in raw material, whether it's in a roll as feedstock, or if it comes as balls or in raw feedstock, or as powder, depending. In this case, it's a string of plastic PLA material that runs through the printer head and gets melted at a particular point so that it's deposited. Okay, that's material extrusion. Material jetting, and it dries basically layer by layer. So the elevated platform there moves up and down. So depending on the type of printer you have, the tolerances you have, how much you're willing to spend, a whole bunch of things, the amount that layer moves or deposited can be it could be up to, if I seen correctly, down to thousandths of an inch if you absolutely need it for certain applications. Material jetting is another common one. So the difference between material extrusion and material jetting is what they commonly call is more commonly known as, let's say, inkjet. So your typical inkjet printer where it deposits droplets to form a print. This does the same thing where it has droplets that form a print based on, of course, the design you have, but it also has an added, as it deposits and prints layer by layer, it also cures. It has a UV lamp that actually cures the deposit in the material as layer by layer. So it's very rapid, no pun intended, they're very rapid production in terms of depositing and curing, where the material extrusion here just lets the curation occur based on the type of material you're using. So there's no added capability of curing with this type of function. The third one I'll talk about is stereolithography, SLA, which, as I mentioned earlier, was the photopolymerization or polypolymerization, which I saw at the Netherlands Air Force. So as I mentioned, there's a kind of a tank of, in this case, resin that is curable by the use of UV light. So there's a laser that basically shines, again, is based on X and Y coordinates, burns or solidifies the curable resin layer by layer. So this elevator goes up and you cure it, and it cures as it moves. That's a very common one as well. And then the last one is powdered bed fusion, especially for metallic components. This is a very similar one to the SLA, but instead of using curable resin, it uses powder. And so metallic powders are a great example of that. And so same thing, you've got a printer head just like the other ones that move in X and Y fashion. And as it essentially heats up the powder to essentially make it malleable and cure, it does it again layer by layer depending on the needs. And so I don't know if you'll be able to see this. It'll be very challenging to do, but I don't think you'll be able to see it very closely. But here, if you look at the metal product that I have in my hand, you can actually see each ring of a layer, just like you would core a tree and you see the rings of the core of the trunk. You can see that here as well, the way they've produced this particular part and how many layers. So I mean, if I look at this, yeah, maybe there's probably at least 300 layers or so is by an estimate. So depends on the type of, again, you have a decision to make when you are producing a part, material and approach or type, because each of these ones have their own approaches to tolerances and their own approaches to production speed, size and area. So if you want to make a large product versus a small product, the type of material, you can't use material extrusion for metals. It's more commonly used as powder versus stereolithography is a little bit more accurate. So depends on the type of what you want out of your product. And again, goes back to that design process of product design. You start with what your needs are for your product, and then you go and select the type. And again, there are companies out there that offer expertise in each one of these or all of them. So that then, of course, drives your procurement process. So I said I'd talk about first principles. And so again, I'll take an example of something I printed with the Ultimaker 2, and I'll walk you through kind of the various stages. So if any of you have the expertise in product design, this might be a bit, or 3D printing and a bit more expertise level, you've probably heard this before. But for those that are new to it, it's a really good methodology to follow if you're not sure where to start. So first principles of design. So when you're 3D printing someone, not yet, maybe soon. When you're 3D printing a product, you start with a file. All right. So the printer itself, all it does is follow a set of code that says, I have to go here, deposit this much. I have to go there, deposit this much. That's all it does. But it's doing that based on a file you provided. That's typically what's called an STL file. And so if you look here on the right, I have loaded a file into the printer, and the printer software actually shows me, okay, well, if you want, where do you want me to print? Where can I put these particular pieces to print? It represents how long it'll take for me, how much material I'll be able to use, the size that it'll be. I can shrink it and make it bigger and smaller while it's into the printer. But even before I get to this point, I wanted to say, okay, well, what am I trying to do? So in this case, I was like, I would like essentially a coaster. So I was like, I'd like a coaster. It'd be kind of spacey, it'd be cool. And so I did some searching, and I'll talk about some resources at the end about where you can find some of these same stuff. So I was like, well, I'm big on SpaceX. For example, they have when they catch their rockets back from orbit, their first stage, they land on a barge in the ocean. So I found somebody had created a file that allowed me to print essentially the barge and make it as a coffee coaster. Cool. So, right. So I said, well, I took this file, so somebody else created it, and there's larger communities there. You could also create your own file to upload into the printer. So what that file does, it essentially, if you're any familiar with CAD or computer-aided design, you could CAD up a file that you'd like a drawing file or whatnot, and load it in as well. And so whatever it does, these files tell you, okay, I want it this size. These are the points, the X, Y coordinates, how much thickness I have, and all those coordinates and data contained in the file with the image are then captured in the STL file, loaded into the printer. The printer renders them as shown, and that helps. Now, when it comes to designing, especially if you're designing your own product, you have to take into account a number of different things. Very, very briefly, I will mention one, which is, again, the type of material you're choosing to use. Some materials cure faster than others. So why is that important? That's important because you have to understand that if you're building a part like this, that it's going to basically cool down and cure at a certain rate. And so if you decide, so in this case, I'll show you an example of what happened for this particular product. Didn't work out, and that's okay. The beauty about 3D printing is that it's affordable and cheap, especially home-based ones, that you can do as many iterations as you want and not have to cry about the amount that it'll cost. So you can try and tinker with your designs to get your performance. Preparation. So this is great. It looks great here. Some softwares like this one are really great. So if you can see a bit of red on top of this gray piece here. That is telling me that the printer head will have some trouble, or the printer will have trouble trying to make those parts because the tolerance is too narrow. So basically the printer head is bigger than the say space between the parts. So it may not print correctly, or there may be some errors. So that's good to know before you click the print button. So you can go back and adjust your file, re-upload, and the like. The other thing to consider is, and I'll show you this, you can see here on the gold image that there's a shadow. So this particular piece that I'm building had an overhang on the edges. And because I used this particular file from someone else in the community that had generated it, it did not come with any supports. So one of the things that you can do in some of the manufacturing types that I talked about earlier is you have to build in supports for certain types of products. So even the way I've produced this, I realized after the fact, I probably should have produced it printing inverse. And the reason for that was because I didn't have any supports underneath that. As the plastic was curing, it wasn't curing fast enough, so it was warping and bending because there was no, let's say, bracing below. You can build in temporary braces. So when you design your product and design your file, you can actually build in temporary braces. Depending on the material you use, they can be dissolved really easily after the fact, or they can be sanded down. That all comes in post-processing. So build. All right, you're ready to go. You've got your part. You click the print button. And what it's going to do, it's going to load up in this case, the PLA. It's going to pass it through the print head nozzle. It's going to heat it up, and then it's going to deposit it in the areas that you wish to deposit it based on the file and guidance you provided. So the printer is not the smarts. the smarts come from how you design your product, design your system, and plug your file in there. So a lot of companies out there, that's where their advantage is. The advantage isn't printing the print button and the hardware. It's in the preparation and the design to make sure that the product you're going to get on the first run is going to do what you want to do. So build time takes its time. Then there's post-processing, right? So we'll stick to the build. So here you can see I started printing the barge for SpaceX. And so what the printer did in this case, was layer down temporary plastic. So all this stuff around the edges actually was not part of the product. The printer did that in order to ensure it had a print area to stay within and ensure that it had the ability to know where to find certain things. Well, you can probably hear this. So this was the, as I mentioned, the rose that I 3D printed. So if you've never seen one before, a printer in action, this is what it is. So it's layering the plastic one ring at a time. And as you can see, it's very, very thin, right? So it's this plate that is moving at a very slow rate, but it's all programmed in to that STL file to tell the printer, you must, this is a certain thickness that I need, and you need to move the plate at a certain frequency to ensure that the layers being deposited are of certain thickness. You can see how I was doing it. And if you look at, so that's making the base, and I'll show you the base of the actual product. Again, my focus is not there, but you can kind of see there's rings, a bit translucent in the middle base. So that it started forming that, and the printer went up. Sorry, the glass plate went down so that the printer head could build up. Now post-processing. So everybody thinks, oh, I press print, it comes out of the printer, it's ready to go, I can go on my way. You can't. A lot of people forget that 3D printing is a means to an end. Just like any other manufacturing process, there's going to be things you have to do to ensure that the product is prepared into its final state. So that's called post-processing. Especially if you've ever done post-processing, 3D printing at home, you'll realize this. So again, as I mentioned, that the printer printed out this extra layer around the actual product that I wanted. Well, I have to be able to break those off so I can get the piece that I need. Same kind of thing here, right? Likewise, on the barge itself, you can see here, I mentioned that I didn't have any supports underneath the cantilevers there, so it didn't print correctly, and that's okay. But I could still use this part. So what I had to do is I had to take some sandpaper, some very fine sandpaper, and sand it down to ensure I got rid of all the kind of wispies and the extra piece of material that I didn't need. And then of course on the bottom, so if you look really closely at this one, you can see how the printer actually went and layered the material on. So it's very, very intriguing. And I had to sand a bit on the base to ensure it stayed flat. Don't want my coffee spilling over, right? And then of course, the last piece is delivery integration. So once you've done the post-processing, and these are very, again, these techniques are the same techniques you would use on an industrial scale as you would at home. Delivery integration, your product and piece is ready to go. They pop your piece in the mail, and then it's received by your supplier or by within part of your supply chain. You enter it into your manufacturing process, and you add it, you add it into your piece and your overall product and test. So that's a bit about the production and things to consider when you are choosing to use additive manufacturing as an approach. Now, what are some of the benefits? We're talking about it's cost effective by volume. So again, as I mentioned earlier, it's very much affordable to do these types of things because you can have a scale of productivity that you didn't have earlier when it came to more expensive and more high tolerance other production capabilities. Again, CNC machining, you can get really, really, really good accuracy. 3D printing, you can as well. It's built itself up over the years. But in some cases where you need very, very tight tolerances, sometimes additive manufacturing doesn't get it for you. But again, it depends on what the application of your product is going to be. Intricate designs. So traditionally, of course, a lot of the other methods are sometimes manual related. You've got a mill or a lathe, and you've got someone operating that, or you've got a set of code. But it's very challenging to make very intricate designs. With 3D printing, you can make a very, very, to be able to produce this by a traditional means of manufacturing would be very, very time consuming and very costly. But if you look at the way that how complex this actually is on the inside, additive manufacturing, it didn't think twice, right? It was very, very straightforward and little waste as well. You're only using as much as you can. I'll talk about it in a second. You can focus control on your supply chain. So, there's a lot of vertically integrated companies out there that are engaging 3D printing as part of their supply chain embedded at their, in their home facilities to add to that. So they have the control of it rather than depending on external sources and external procurement. Lead times for parts are produced. So, if I wanted to create one of these with traditional would take quite a long time. And if I needed to send out 50 for Valentine's Day or whatever, and I'm 2 days out or whatever, it's not going to be done, right? So you can do a lot more quickly with additive manufacturing. And what I haven't shown here, because it's a bit more costly, and the machines and tools I was using didn't lend itself to it. But you can actually use multiple materials simultaneously in 3D printing, whereas traditional other modes of manufacturing, you have to do kind of a cast of a part, and then you have to add a ceramic layer with the spray or a specific paint or something. You can do all those types of things in one shot with additive manufacturing. So one example I like to use that I saw at the Rapid conference in 2016 was the world's first 3D printed semiconductor. So for those of you in the electrical world, the fact that you can print a semiconductor in its entirety in one go, that is incredible. But that means you're using materials that are plastic or composite. You're using materials that are can pass and be conductive and pass electricity. And so if you've ever seen a printed circuit board, they were essentially printing circuit boards with a 3D printer rather than the typical approach to PCB manufacturing, which generally takes a lot more space, a lot more time, a lot of conveyor belts, and sinks and a lot of things. So again, you can do a lot more than you might think. Some challenges, of course, it's not all rosy, because with everything, there's always some challenges to worry about. The purity of material properties. So for those of you that come from the material property world or are interested in material selection, 3D printing is wonderful. But again, it depends on you choosing the right material for your application of product. The strength of materials, of course, you've got a great metal produced product here, excellent. But depending on your application, if you need extreme purity of your material, you basically have to essentially print in a vacuum. And so there's certain powders, when that metallic powder is then cured, if you induce air into that curation process, you're going to have gaps and deformities within the material property of that metal. So what does that mean? That means you actually lose in some cases, some strength or capability of the material that you are intending to use, because it has built-in cavities within the molecular, down to molecular level of how the material is cured. So in some cases, if you need high performance parts that don't have those kinds of issues, you have to essentially print in a vacuum-based environment where you're not inducing external influences, and the material can cure evenly and consistently as it needs to in order to make your part produced. So things to think about. Supported designs that I mentioned with my example part there, supporting those designs, how you place and produce the part, if you're working on industrial scale with some partners, they'll be able to walk you through that. But you also have to understand that there are going to be times when you might have a little bit of waste, because you have to support your design to get the end product that you're looking for. Tolerances, and I'm going to talk about tolerances from a batch production perspective. So there's been a lot of work to try and understand how can we use 3D printing and additive manufacturing for batch production with multiple printers. So if any of you know, and if you ever try to use a tool for something, you always have to go and make sure it's all calibrated correctly, make sure it's all going to do what you want it to do, and ensure that you have record and audit trail keeping. Well, if you have multiple printers, the tolerances are going to inherently in the design of the tool are going to change. So if you have a part that you have a very, very narrow tolerance to hit, perhaps a batch production with multiple printers, you're going to have a little bit of variance if you use different printers. And so in the couple examples I'll show you here, especially the one of relativity space, they created their own 3D printing capability in order to produce their rocket ship. But they've limited it to 1 or 2 units, because they know that if they use multiple printers or multiple sets, they're going to induce a variance that they really don't need, especially when you're using a production capability like launching a rocket. Waste and reuse. So a lot of the powder, for example, the powder that you saw could be used for metallic production. That powder can be reused a certain amount of times until it reduces in purity. So you have the opportunity there. Same thing with the resin. The resin that isn't cured can again be put back into a reservoir and reused. But there is sometimes a little bit of waste that is generated. So depending on, again, on what your production part is, you can put multiple parts, of course, in one process. So there's a way to minimize waste, again, depending on the type of product you're using. And maximizing in situ versus post-production needs. So what does that mean? So as I mentioned, there's going to be post-processing that required. You're not going to get your part out and say, hey, I'm going to go, print a straw and then use it. Well, you're going to have to make sure it doesn't cut you if you decide to do it that way. So there's always going to be post-production. So based on your supply chain and based on your production process, can you build that time in, or can you build that piece in to ensure that you get what you need? There are companies out there that literally focus only on post-production. They don't do the printing, they don't do the setup. All they do is take your printed part, for example, a metal part, give it the nice finish or the polish or the smoothness that you need and send it back. So those are things that have to be considered, that if you wanted to bring your whole supply chain within additive manufacturing in-house, you can do that. There are companies that do that. But that's obviously a lot more investment in terms of the capital for your hardware and your equipment versus, and that's the trade-off you would do with your business, is to, okay, well, maybe I can do a bit and then send it out and contract it out depending on your needs. So I talked about a lot about 3D printing in terms of its basics, and I alluded to a few things. Applications. This is just a snapshot. There are many more applications than this, but I'll touch on each one. Surprisingly, retail, if you didn't know, Adidas, for example, engages 3D printing to print the soles of some of their shoes. Right, it's great. It's cheap. It's a material that you can get really easily. You can custom design it to your needs, especially for their products, and especially on a batch production level, where if it's an insole, you don't really need as much, your tolerances are a little bit less because there's some give and play. So that's okay. This was an opportunity where they identified that they could work with a little bit less or be more, flexible with their tolerancing. If you jump into aerospace, as I mentioned, of course, rockets, 3D printing, being 3D printed now is incredible. But there's also been a lot of parts in the aviation industry, like GE. So GE Aviation is a leader in the industrial 3D printing. They've been doing it and studying it for decades, but they've also been able to perfect the art of additive manufacturing, especially for metallic components and high stress and high tensile environments. So, for example, the fins that you see on a jet engine, for example, they've been working on perfecting that. The connection piece between the actual aircraft engine and the wing, that's 3D printed components from GE. We look at Boeing, for example, they've been quietly using additive manufacturing to design basically the cabin airflow, like the ventilation for the cabins in the aircraft. So those are 3D printed plastic parts. So you may not realize it, but there's a lot of 3D printing being used already. And these are examples that are been used over the past several years. This is nothing new. Construction is an area where disruption is ripe, in addition to some of the other areas. And I'll talk a bit about, okay, well, how do you apply the same methodology of what additive manufacturing is into construction? Companies like, Caterpillar are investigating it. I've had, conversations with them. So there are now, not only service companies as part of the construction industry, but also the construction as a whole are really trying to understand how we can enable technologies like 3D printing to build up capability. Automotive, of course, car production and parts production, there's thousands of parts that go into building a vehicle. A number of those are now 3D printed, depending again on the use and the application of the product. I've worked in the automotive sector. I understand that there's, your big majors, so the people, the Fords and GMs of the world that, of course, outsource certain pieces to tier 1, 2, and 3 suppliers that are now engaging 3D printing to provide similar parts, as well as warranty parts as well. Food service, people don't realize it, there's actually 3D printed food coming. So again, it was the semiconductors, it was multi-layer materials, carbon fiber. Now we're looking at food and 3D printing food. So yes, it is a thing. There are companies and visionary people that are working on making that a reality. And in the medical field, absolutely, when it comes to medical grade materials, you can get really, really high, really specific, intricate needs, especially when it comes to, say, you're looking at a carbon nanotube design where it's a graft, not a carbon nanotube, but a graft design tube, whether it's pacemakers in terms of the exterior ones that are, when you have the capability to control your entire process, and even models. So a lot of the models you might see that are used for training and educational purposes in the medical world also 3D printed, because you have the ability to do that. I know there are folks that actually use 3D printing not for their finished product, but for their interim product. So if you're looking for, there was a team that is sending, actually, hopefully soon, a small satellite to the moon. It's about the size of a loaf of bread, maybe a little larger. And so they had very tight tolerances of trying to fit all their systems into the, essentially into the structure of the satellite. So what do? They actually 3D printed all the components they knew that were going to go into the satellite, into certain subsystems, to arrange it within that canister to make sure that it fit, that they could test, okay, where their wire harness is going to be, making sure there was no interference with the covers or the ejector mechanism that would release the satellite. They did a lot in preparation as a prototype prior to actually developing their actual their final product or their flight model. So that's where 3D printing comes into play. Traditionally used for prototyping, but now is beginning to be used for final production. I mentioned that HP, let's say, is the mainstream 3D printer. This is their patented technology, which is called MJF, multi-jet function. And so what it does is that it's that approach. So it's their proprietary technology. But if you looked closely, I'll just replay it again so you see it. So it's depositing just like an inkjet printer, but it's also got a curable light, right? So as they're depositing, they're curing. As they're depositing, they're curing. So that's making the manufacturing process extremely quick. So this is used for certain applications. What they don't show you here is this is one unit of 3. Of course, everybody wants to sell more things. This unit, if I remember correctly, was probably about 250 to 300,000. But it is the ability to, you could put it in your office, just like you have your normal plotters or your normal paper printers. HP is trying to bring that into the mainstream. They actually have 2 other units very similar to this that support post-processing. Remember, you can't just take the piece out of here. You have to do some work on it before it's production ready or use ready. You can see in the side here on the right, they use the resin or the powder that they use to make it. So that's, the cartridges that they swap in and out. So they've got a bunch of added, if you buy the whole system and run, you probably $700-800, under $1,000 at the time. That was a few years ago. But things, of course, have moved on since then. But again, we've got some great examples here. I mentioned construction. So 3D printing concrete, or what's trademarked as contour crafting. There was a professor from the University of Southern California who has been working on this for decades and has owns a patent, has now really spun out a company that does it. What they do is essentially 3D print concrete. And so if you could think of, you are in, you don't have to, it's very, all the labor that has traditionally gone into concrete laying, concrete pouring is removed with this process. So the amount of costs related to that, the production time that you could save, the tolerance you could get, and the really rapid production you could build. There are companies anywhere in China as well as in North America that and Europe that are honing this technique to be able to build structures within a day. All right, let that sink in. If you could build a structure in a day, especially in areas that are hard to reach or deprived in impoverished areas that could really use quality housing. I mean, this is revolutionary, right? So this is another really good example of disruption in construction. And then I mentioned relativity space at the top, 3D printing an entire rocket. And this is their system that they developed and built and honed over the years. that again founded 2015, and that this is very 2020. There you go. Literally and entirely the engine, nozzle, the body of the rocket. This is actually what you see here is the tanks that hold the liquid oxygen, liquid and kerosene and the like that are used by the rocket. So they're developing their own rocket. So they're not producing these for others. They're building as part of their own production process. So that's an opportunity. It's called the Terran, if you're interested in following up on that. So this is the capability and the flexibility that additive manufacturing and 3D printing allows you the opportunity to do. To do this even 5 years ago without 3D printing would be 10 times costly, and you wouldn't get the time. It would take a lot longer to do. So there are advantages that I mentioned off the top. I wanted to touch a bit more on the market and engagement. So as I mentioned, a lot of the focus, 3D printing in terms of the idea has been around since the 60s, but really didn't mature into conception about 1980s, where people started producing patents, companies were founded, for example, 3D Systems. And so they started, saying, okay, well, let's build the hardware to go with the idea, right? And then like any good product and good idea, a lot of research and development went in. They started focusing on, okay, well, it's very expensive, offshoots to do one-off. So let's try and look at prototyping and how can we support that industry of prototyping, all right? And then starting to get into iterative design and how do we make products better? How do you support design of products? And then of course, like anything else, we've got, 1980s, we didn't have these. So that is, like technology growing at the pace that it does, doubling every 5 years, right? The growth and adoption stage hit with the 2000s. Raw materials were more available. We had accessible, more affordable technology, generative design, and started implementing some smarts and some intuition into design process. Those all started occurring all around the same time. And that's, in my mind, when the market in terms of additive manufacturing started to really be taken on seriously in supply chains. And then, of course, with the classic innovation and adoption curve, it takes, there's the early adopters, there's those that hit it at the mark, and then there's the laggards. And so the DIY movement was created. We took the traditional technologies of 3D printing, which were very expensive, miniaturized them, put them in your homes. And so over this long time, the what's called print area, so the area in which you can print a product, has been very small. Even as recently as 5 years ago, the largest print area 5 years ago was 1 foot by 1 foot by 1 foot. You couldn't print anything bigger than that. Now you've got people that are printing rockets. You've got people that are printing a number of different other products, and the capabilities have grown and technology has evolved such that we're able to expand that boundary and not be limited. And so the different types of materials that you have, the embedded autonomous systems now that some of these printers are very, very capable of doing. And then, of course, this diversified supply chain. You now have not only the hardware production, you've got companies that are dedicated strictly to servicing post-processing, that are just strictly towards how do you maximize the design or optimize the design of your product so that it will 3D print the way you want it to, right? All these pieces, raw material production, you've got the folks that are making, say, the raw materials for the metals. You get the largest metal production companies in the world are in on producing the raw feedstock for 3D metal printing. So this is all come over the last 30 years. And so if you look at, I kind of look at that as well, with the commercial space sector is very similar in terms of the timelines, and is very similar in terms of what's going on in the market, where the consolidation is now happening, where people are embracing and adopting this technology. 3D printing and additive manufacturing is following a very similar trend and very similar market evolution. In terms of market leaders, we've got companies like Stratasys, which is world leader. Companies like 3D Systems, which 3D Systems was the first patent on a 3D printer in the 80s. They got companies like X1 literally yesterday. And when I talked about this market evolution, about consolidation, literally yesterday, X1 just got a public company, just got purchased and acquired by Desktop Metal Co. In terms of expanding their breadth and swath of capabilities in metal, sand, and ceramic manufacturing. So it's happening literally before our eyes in terms of consolidations in the sector. A number of these are market leaders by market capitalization, as well as some of their production and how I've tracked it. Full disclosure, I do hold stock in some of these companies, but they are very, very capable in terms of what they're doing for the industry. HP is on there with the plastics focus, right? We've got Autodesk. Autodesk, if any of you are not familiar with Autodesk, some of you on the West Coast in San Francisco probably are. Autodesk is essentially what I call a 3D printing services company. They're very, very, they have been studying and researching 3D printing for a long time, but they bring in a lot of added value servicing. And so what they've done is they've actually said, okay, well, yes, you can go produce your part, and they've been working with 3D printing companies and as well as clients to be able to prepare parts that will really work for your needs. They've really patented, or not patented, but they've come up with a generative design model that they're really, really hitting on, is where if you've ever seen the video of, here's a normal chair designed, 4 legs and a seat and a backrest. Let's use artificial intelligence and understand, okay, well, and methods and typical design philosophies and material properties and the like. Put that into the computer, see what it comes out with in terms of a design of a chair. The end product design over iterative and generative design and iterative design, but doing it on a very, very fast pace. We're talking about millions of designs in a second. Optimize the design of a chair, and you'll actually come up with if you watch the video, it actually comes up with the design of a chair that actually only has 3 legs rather than 4, and does not look like a chair, but does exactly everything you need in terms of form, function, and design of that product. That's an Autodesk thing. And so if you have the chance to visit San Francisco, go down to Pier 9, they've got an entire facility there dedicated to 3D printing, about working on robotics, the 3D printing of materials, material selection, services. They support the upfront scanning. So some people like to reverse engineer certain products. So they're developing scanners that you can scan essentially a product, make a 3D rendering, and then print it for yourself. So that's a little bit of that diversity in the market of 3D printing and additive manufacturing I'm talking about is where Autodesk is one of many players that provide that as well. So you might wonder, okay, well, how can I keep myself informed and engaged? Again, you can, if you're on the technical side, have a look at the ASTM, National Committee on Additive Manufacturers, from a standards perspective and a development perspective. Check out Autodesk. They've got a lot of free resources that you can use to help get yourself familiar with the 3D printing and additive manufacturing world, but also stuff you can install on your phones, like the 3D scanner I mentioned. They've got a phone app, you can actually scan it and it'll give you the 3D representation on your phone. Industry, one of the great reports out there, the industry consultants of the additive manufacturing world, is the Warlord report. It's not cheap, but it gives you an annual scan of the entire 3D printing market. Of course, the other thing I enjoy doing and would recommend you do is get out to one of these conferences. Annually, the Rapid TCT conferences in June. They're bringing back now in-person conferences, of course, due to COVID. But definitely something, if you're engaged in any part of the supply chain of additive manufacturing, get out there. You will see and learn a lot. And that's actually where I got this 3D printed metal Orion from, is it was a company that was focusing on 3D printing for aerospace applications. That was one metal product that they were doing, and they were looking at, for example, 3D printing rocket fuel. So, the world is our oyster. If you're interested in kind of getting your feet wet at home in the DIY space or the maker space, you can get yourself like the Util Maker 2 Plus. Is a really great, easy, and simple printer to use. If you're not familiar with the technical side of AutoCAD or 3D design, you don't need to know any of that. It really, really helps to get your feet wet. Those run anywhere from $1,000 to $5,000 for that particular brand and type. But you can go on Amazon and get yourself a 3D printer at home if you're more technically savvy, and it comes, it doesn't have the nice container. It just got, X, Y, and you can build it yourself, even to the extent where you can produce the PCB yourself if you wanted to, for hundreds of dollars. So it's becoming more and more affordable for people to try that. Like sometimes I wish I was going to work in the garage. I wish I had my 3D printer so I could print X, a bolt or a nut or something, or a connecting piece that just to give me that flexibility. It really helps. Some of these references here: 3D Universe, Tinkercad, Thingiverse, Selva 3D. These are various different communities out there where people develop their own STL files or CAD files that you can use. So if I'm looking to print I look to print the SpaceX barge, found that out there. People that are passionate about the things that they're passionate about then turn to the maker spaces to be able to share that with the community, and things like that. So certainly things to think about. This here is it's a very busy slide. These are all the 3D printing conferences that are out there right now. You can see there's a bunch that have not yet been scheduled for good reasons, but there is a lot of activity, not only globally, but also regionally. So if you're interested, definitely get out there and get yourself to a conference and get familiarized. I will share a story at the Rapid conference that I went to, and this is where I realized that additive manufacturing and 3D printing were going to be very, very critical in the future of production. And the opening remarks by the head of the organization at Rapid, what they traditionally would do is at that particular talk, they would summarize the last year's progress in terms of the additive manufacturing space. This was the first year, this was 2016, when there was so much progress in the AM space, they could only cover not even half the year's progress of what has happened in the year. Right? And that was 2016. Now you can imagine how fast things have progressed since then. So if you're very interested in this area, please get out there and get plugged in. So with that, I took a little bit more time than the allotted, but if there are some questions, I'm happy to take them, and hopefully this was helpful to give you an idea and a little glimpse into the capabilities of additive manufacturing and 3D printing. Thanks again, and I appreciate your time. I don't know if Arslan, if you're on mute by any chance.
Yeah. So we'll open it up for Q&A now. If anyone has any questions, feel free to drop it in the chat. Keeping an eye out, or feel free to unmute yourself and ask away. Because I had one question. How does this play into like environmental concerns? Like, what does the recyclability or like the life cycle of a 3D printed part look like?
Yeah, those are great questions. So there are, so if you look at like the home-based printers, so if you're using PLA or ABS in terms of the materials, sometimes if you print something and it doesn't work, like, luckily this one worked on the first shot, but the couple of the other parts that you might print may not work. Depending on the type of material, it can be recycled into normal recycling waste. That of course also depends on the region in which you are located in. So some cities and municipalities will take those types of products into recycling, others will not. There again, depending on the type of manufacturing, type of printer you have, if you're using the powder based, that could be reused quite a bit. I think if I remember correctly, it was like you could use, at least on the metal side, I think it was up to 7 times. Don't quote me on that, but I think up to 7 times that you can reuse the same resin or that in the powder, the same powder, before it starts losing the quality of product that you need. So a lot of that times when it's laser sintering and curing just the pieces of of the other of the powder, you can reuse that powder over and over again. So the reusability is there. So from that perspective, it's helpful. If you get yourself into a stage where you're looking at, say, composite materials, of course, then if you're layering on certain pieces or you're embedding certain pieces, then you get into the discussion of, well, okay, you have to be a bit more cognizant of the impact of, if that part doesn't work, then how are you going to get rid of it, and whether that goes to electronics recycling or the like, right? There's certain things to consider there as well. So that overall, though, definitely the approach of additive manufacturing when compared to other traditional methods is very good in terms of you're only using what you need to use and doesn't waste as much as other methods would. So from an environmental standpoint, that is important. And like I said, if you're in a situation where you need very, very high tolerance and high performance materials, especially in a scenario where you need to produce your part in a vacuum, for example, those are then you start getting into probably having to have a look at doing what's called a life cycle assessment or a streamlined life cycle assessment on the environmental impacts of your procurement process.
Cool. Thanks for that. We have a couple questions in the chat. I'll start with one of them. Can you talk about careers in 3D printing? Like what sort of education or degree requirements should students pursue if they're interested in this?
Yeah, that's a great question, actually. So like I said, I came from a mechanical engineering background, so a technical background, and understanding that additive manufacturing is a very mechanical process, right? But it combines materials. So there's, if you're, let's say materials engineering, it combines mechatronics. That's what I took. So electrical and mechanical, or electromechanical. That is from the development side of the technology and hardware side of the sector. But and that's one way. So if you're interested in the technical side, and there's opportunities are galore. Literally everything now that is produced in terms of production is additive manufacturing made in some way, shape, or form. At least here in Canada, every academic institution has a 3D printing lab. So you can go in there and get yourself familiar with it, despite what your background is, whether you're in a STEM career or not. You can still have an opportunity to experiment. So if there's opportunities there, especially when it comes to procurement and supply chain. So if you're in the business side of things, the finance world, being able to use this as part of your toolkit to make suggestions to improve your company's supply chain. You can work in all those surrounding, let's say, serviced markets, retail, construction, and bring the capabilities and discussion of capabilities of additive manufacturing into those sectors, right? So you don't have to be an expert in additive manufacturing to do that. You can maybe be working in one of those other sectors and knowing that there's some added value that you could bring to your production process, cost savings, environmental considerations, control of supply chain efficiencies, right? To make sure you're consolidating your bottom line. So there's a lot of different ways you can engage in the sector, and so it all really depends on what your interests are and if that works and how you can apply that. So again, very similar to the space sector, where it takes a bit of all these different sectors, finance, procurement, material selection, engineering, marketing, communications. Like HP is not going to go out and do that unless they've got some really good quality marketing approaches behind that too, right? So there's a lot that can be done within the additive manufacturing space, depending on what your preferences are.
Cool, thank you. Someone also asked, I know you touched about on this a little bit, but can you talk a little bit about 3D printing houses and how that compares cost-wise to traditional methods?
Yeah, there are obviously construction standards right now that if you're going to go build a house, you have to follow certain standards in the jurisdiction that you're located on. So if I wanted to go and build my 3D constructed house tomorrow, I might be challenged by getting permits to be able to do that. But what it means, but if you look at regions such as China, or approaches where you can, let's say, prefab certain pieces. So I know there are needs with certain industries where they have to, say, for example, build explosion-proof control centers, right? So you could do that by 3D printing the slabs and pieces, and then installing them and then fabricating them together on the site that you're at, right? So there's different ways that you can engage in the supply chain. Additive manufacturing doesn't mean you have to do it all by additive, right? And I think there's still a lot of work to be done to bring to light the capabilities that are out there, especially in more traditional markets. And that's always going to be the case with anything, right? With any new disruptive technology that has added value, it's kind of that give and take between, okay, well, how far, just like drones and aviation, how do you, in some cases they have to change legalities of certain things to allow or not allow drone flights in certain areas, or get people licensed to fly drones in certain ways so that they are capable, right? So there's still going to be push, especially in the construction industry. It's still very traditional, and that's not a bad thing. It's just how it effectively works and what people that engage construction services are used to. But that doesn't mean that it can't be disrupted with technologies like this, which people are trying to do. But again, it depends on the region of the world that you're in. I know China has produced a lot, and you know, there's a bunch of videos online that you can see about what they've been able to do with that technology. But again, I think there's a room for discussion on, okay, well, how do we use benefits of this? Like, say, okay, it's not for residential housing, but maybe for temporary housing. Like, say, for example, if you've got a set of trailers on a construction site, maybe we could, you know, those trailers to be built with an additive manufacturing process rather than being the actual, you know, to support the actual construction of a particular unit. So there is still a lot of tests, of course, that have to go on our way. You know, ASTM not only does additive manufacturing, but they do everything else, especially when it comes to codes and standards around the cement curing and how strong cement has to be, about you know, certain MPAs per square inch, yada yada yada. So there's a lot there too, right? That has to be understood. Okay, well, you know, can we keep the discussion going about, all right, let's produce something, let's do some, you know, strength and tensile tests and compression tests on various types of products made with different types of materials, and continue going down that route to say, okay, when you get to a point where something is producing, especially like some of the work I investigated on concrete was 2016 related, but if it came today, maybe there's been lots of improvement in not only the fabrication and the materials used and the deposition and the strength and the curing time, that maybe we could make you know, not only a 1-story unit, but maybe a 3-story unit, you know, and then at some point will we get to producing you know, high rises with the same functionality? I think so. So that probably doesn't answer your question entirely, but at least gives you an idea of where things are at and the approaches that are being taken today to ensure that, you know, 3, 5, 7 years from now, that when codes and standards are updated to accommodate new technologies, then there's an opportunity there to make use of them.
Cool, thank you. Last question, and then we'll wrap it up. Is, if you have an entrepreneurial spirit, have you seen people, like, you know, use DIY printers or low cost 3D printers and then try to like make that into a business or supply products?
Yes, yeah. So if you know, if any of you are familiar with Etsy and the, you know, the craft, you know, the craft, you know, I build, you pay, you know, one-off for very specific types of fashion, jewelry, you know, clothing, right? There are people out there that have actually bought 3D printers and make stuff with their 3D printers to sell and make businesses out of them. Very entrepreneurial spirit. Some have done it just kind of on the side as hobbies. Others have turned it into more mainstream productions. Like, I've seen people that have used their 3D printers for, again, mainly prototyping to support their work. So whether in the medical field, you know, they're trying to understand, okay, if they're building a robotic mechanism to support surgeries, that what can they do in terms of a tool that they might be able to add, or certain support mechanisms they can build or print that are medically grade that can support that type of thing. If you look at aviation, if you own a drone or like a home drone, like the small ones, right, and you have a broken piece, then people have been able to take their 3D printers, try and find the part online or recreate or draw the part if they got the technical aptitude to do so, and then print it and then try it, you know, fix it themselves, right? No need to go back to the supplier to buy and spend 2, 3, you know, times the price. So while there's, yeah, if you're entrepreneurial, there's absolutely ways to do it. People are looking at food production, people are looking at semiconductor production, people are looking at aerospace production, and yes, you can't do everything in your house, but you can gain the same necessary skills you would need to understand how to fit that into a process or put that into a supply chain, that when you take it to the industrial scale, it does scale up. And so that is exactly what the relativity space guys did, where they started literally with the small printer that they had at home and finagled and figured it out, and then just scaled to the point where they realized that the optimal way to do it was build their own printer to get their own capability and tolerances, and have now, you know, raised $500 million to build rockets that go to space that are 3D printed. So yeah, if you're out there trying to have an idea, you want to test it out, absolutely. I encourage you to try the DIY stuff, or if you don't have access to it, hop over to your local libraries. Even the local library here has a 3D printer you can book and get some time on and familiarize yourself with it. And then once you have the opportunity to perhaps purchase one yourself to work on it more at home, or if you have a garage or a mechanic's garage that you do some work in, great place for it as well. Even toys, right? If you're looking to make some toys for your kids and get them engaged in a creative way to make a design and print it and teach them that way, there's a number of different ways you could do it. And so I would say, like any good entrepreneur, find the pain point of what you are trying to serve, whether that's a product or service, and really hone that, and then understand really deeply how you could use additive manufacturing to support that, solving that pain point or need.
Awesome. Well, with that, Tahir, thank you so much for a wonderful talk. And being a mechanical engineer myself, I feel like I still learned so much today. And so I think that was a really awesome presentation. Great questions from the audience. I just wanted to let everyone know that we encourage these conversations about not only this topic, but any hardware related topic on our Slack channel. And so if you're not yet part of the IP and hardware Slack channel, we can get you on, and we're happy to support these conversations and even one-on-one things in that forum. So, and yeah, thank you again, Tyler, and hopefully we'll get some other presentations in the pipeline as well.
Awesome. And thanks again to the IPN team as well for setting this up. I think it's, again, I said off the top, great opportunity to connect, and please continue doing what you're doing, because it's very, very valuable, especially for those across our community that are interested in expanding their horizons and boundaries. So thanks so much.
Cool. All right. With that, we will end the session today.